Hello, dear viewers. Today, we will talk about an important element for plant health, silicon. Let's discuss how silicon affects the growth and development of plants, especially in conditions of soil salinity. Let's get started. Saline soils contain an excess of soluble salts, hindering the absorption of water by plants from the soil. Saline soils have a high concentration of adsorbed sodium, leading to the breakdown of soil structure. The soil becomes very dense when dry and sticky when wet. Both saline and saline-alkali soils significantly reduce the productivity of agricultural production. Many scientists worldwide have studied the properties of silicon and its impact on crop yields in agriculture, especially in saline soils. Liang Xingguan, a Chinese scientist who made significant contributions to studying the influence of silicon on plant resistance to stresses such as salinity and drought. Emil Epstein, an American plant physiologist who conducted research on the influence of silicon on plant physiology and its role in strengthening cell walls. Yangsong Kai, a Chinese scientist working in the field of agronomy and plant physiology, investigating the effects of silicon on plant growth and resistance to diseases. Klaus Schroeder, a German biologist who conducted research on the influence of silicon on plant physiology and biochemistry. Drawing extensive experience from these studies and field results, the AminoSid brand has developed the AminoSid silicon product. Silicon is a micronutrient essential for many plants, as it is part of cell walls, providing them with strength. Silicon can be particularly beneficial for plants growing in saline soils, where they often face various stress factors: increased osmotic activity of salt, low soil moisture content. Researchers have identified the main properties of AminoSid silicon in saline soils, reducing the impact of salt on plants, strengthening cell walls, enhancing resistance to drought, providing stress protection. AminoSid silicon can help reduce the negative impact of salt on plants, improving their resistance to soil salinity. AminoSid silicon strengthens plant cell walls, crucial in conditions of salinity where cell structures may become more fragile. AminoSid silicon helps plants use water more efficiently, particularly crucial in conditions of water scarcity in saline soils. In saline conditions, plants undergo stress, and AminoSid silicon can alleviate this stress, promoting normal growth and development. The father of modern agronomy, Justus von Liebig, published a book in 1840 titled Organic Chemistry in its application to agriculture and physiology. In this book, he provided the first scientific justification for the application of fertilizers, stating that to obtain a good harvest, it is necessary to introduce nitrogen, phosphorus, potassium, and silicon. He emphasized these four elements of nutrition, not just the traditional 3 NPK. In this photograph, you can see the results of applying AminoSid silicon. Humphrey Davy, whose name is associated with nitrogen, wrote in 1813 that silicon accumulates in the epidermal tissues of plants, protecting them from insect pests. The application of AminoSid silicon in crop production contributes to strengthening cell walls, improving resistance to stress, increasing yield, combating diseases and pests, enhancing photosynthesis. It is recommended to apply AminoSid silicon in a dosage of 2 to 5 liters, depending on the plant species and soil salinity. Thank you for watching our video on silicon in crop production. We hope you have learned something new and useful. Subscribe to our channel for more information on agriculture and crop cultivation. Until next time.